Right, so here I'm going to go through what a bubble sort is. In the exam, the only thing they're likely to ask you to do is to perform either a whole bubble sort or maybe a couple of cycles of a bubble sort. So let's go through how you do that. So if they say to you, sort this data, so you're going to draw it underneath like this. You get a box because a bubble sort works in pairs at a time. And you're going to show, basically, you look at these two and you order them correctly. You go like that. So that is now that. And then you would copy this down because this is how it works. Then you would be looking at these two bits of data and you would sort them. Now this, when they say one cycle, they probably mean that one session all the way to the end. I doubt they'd ask you to do any more because it takes ages, a bubble sort. So then you go on to this, they're correct. And you'd go on and on, showing that a bubble sort has happened. There's nothing here. Now, just on the off chance, right, and then they'd probably say do one cycle, okay? Excuse me. So let's take a look at one where it's complete, because there is one thing that sometimes students make a mistake. They might ask you. So that's what. Then this would be repeated over and over again, this cycle, until not just until the data was correct. That's a common one. The kids will see at the bottom the data. Oh, it's sorted now. We're done. But the problem is the computer has to go through a whole one of these and find out there are no flips before it's finished. So let's just delete this all back here and change the data so that it's very easy to sort. So let's make this 2, 1, 3. Okay, so now we've got some easy data. Then we copy this down. Brilliant. First step. I'm actually, just after the first step, we're technically done. Obviously, the computer doesn't know that. So we'd need to go through. The computer would go through, checking it all like this. Go through. Checking them ones. Checking them ones. Checking them. In fact, I'm going to delete this number just for speed. Right, okay. So you might think, it's done. That's the end of the sort. But actually, it does it because the computer, we know this is sorted data because we can see it, but the computer doesn't. All it knows is it did a flip this turn. It flipped here. So what it does with a bubble sort is there's a variable saying like, did we do a flip? It starts it at false before it starts the sort. And then as we go down, yeah, so no flip, and then flip. Oh, we did a flip. So then we've got to set this to true. And by flip, I mean we swapped something here. Or it's normally called a swap. I don't mind calling it a flip because everyone calls it a swap. So I'll call it a swap. Okay, now then what happened is, gets to the bottom, and all the computer knows is there was a swap. So for all it's concerned is the data's moved. Now this here could actually be, I mean obviously we didn't have any gaps here, but like there could be numbers that still need to be swapped. So what happens is it has to go through a whole other process like this, with swap being false. And then if at the end it hasn't done a swap, like the second cycle, no swap, no swap, no swap, no swap, now it knows that the data is sorted. So just having, I don't know how they could possibly ask this in the exam, but just to make sure that you understand that even if the data is sorted, you have to do one more complete cycle with no swaps to be sure, because there is a possible that it still needs data to be swapped. Right, okay, so that's how you do a bubble sort, not the most exciting sort, not very efficient. The biggest problem for bubble sort is that, let's say this was 1, and that could be true, by the way. If you could have two numbers the same, they just would just be next to each other and not swapped when they're compared. But basically, this would only move one at a time. So as it goes through a complete cycle, that would be swapped. As it goes through a complete cycle, that would be swapped. So the problem with bubble sort is if the data is near the end that's wrong, it takes forever. It's a very slow sort, but it is on the curriculum, so there you go. Okay, so now we're moving on to the merge sort. The best thing about a merge sort in the exam is that you don't have to know at all how it does the sorting, because the way you have to answer the question is really, really easy. So let's assume this is the data all in a list. There you go, and we're going to merge sort this. So the first thing you do is break it up into, because at the moment that's one list, okay? So what you then do is break it up into individual lists, all of their own. I know it looks like they are now, but often they do it in like a box, so it might be in a table. So you break it up into individual lists. So that's step 1. Okay, split into individual lists. Right, so they're all on their own list. Then what you do is you basically start off by doing them in twos. Then what you do is you copy these down into twos, but you sort them at the same time. So like that. Now normally be boxes around these, but I haven't got boxes around them. I'll do that again in the next one. Then these come down, 345. These come down into the right order. Okay, and if there's one left, it's on its own. Okay, you can draw arrows between all these if you want, and then draw arrows, but that's basically what happens. So, you know, combine and merge as we go. So basically you're going to combine and merge and sort as we go, not merge and sort or combine and sort, whatever. So now we split them into individual lists, so that's ones. Now we did twos where they're in pairs. Now we're going to do fours. So these all come down and they get sorted. Now they're already in order, so that's lucky. And then these come down. If there's ever a number less than the number you're looking for, you just do all of them. So there you go. So now that's come down to here. Okay. So that was in fours, but of course this one didn't have enough, so you just do what you can. Okay. Then last but not least, you merge and combine them as one big long answer like this. And you just get them in the right order and then line them up, draw them nicely out. It's actually a weird question in the exam because it doesn't really explain how this all happens. It just says split them up and then sort them. And you're like, yeah, okay. So here's the example they give you, which is quite good. I'm going to leave that there. So you break it up. They'll often have them in boxes. So maybe you draw them in boxes. I just didn't have time to do that. So you split them up into individual lists. Then you merge and sort each list. Obviously, if you've got a spare one on the end, you don't. What a lot of kids sometimes a mistake. The only big mistake I see kids here is they stick this 22 on the end of this. It's the maximum number of boxes goes from 1, 2, 4. You'll never get more than that. You'll never go 8. Well, 8 will be the final one, but because it'll just be too big. Now, I suppose they could do a 10-digit number and you might get 8 and then 2, but whatever. The point is, you don't just split it into half. You do whatever the number is. So this one's into single lists. This one's into twos. This one's into fours. So even if there was 5 numbers here, it would still be 2, 5, 13, 22, and then whatever's left. You wouldn't do like a 3 and a 2 to try and keep it even. You do 1, 2, 4. So this left box will always be as many as it can be. 1, 2, 4, and then the last box will always be what's left. So in this case, there's 3 left, and then you merge it all together. So that's the merge sort, not the most difficult one. There's 2 questions answered there, so I won't need to do any more questions on the website because I've just done 2, and there's not much difference really. So now we get down to the last of the 3 sorts that might be in the exam, and that is insertion sort. I think it's the least likely to appear in any exam because it has the most annoying steps, and it's quite difficult to really not describe it, but really put it on paper in a neat way. So anyway, the principle of it is that you start with a list of data like this, and then what you do is you basically presume you've got an unsorted list and a sorted list. Okay, so the left digit here, I highlight it green. I'm gonna draw green in it. Okay, so this is the sorted list. This becomes sorted. Probably going to put S and U, and then this is your unsorted list. So that's the start. I'm just going to put unsorted, but from after this point, I'll just put U and S, or I won't bother writing the letters at all. So sorted, unsorted, right? Because obviously that's a list of 1, so it's definitely sorted. And this is an unsorted list. So what you do is you basically have to copy it down every time. Actually, I'm going to get this one here. Is you then go, right, I'm going to look at the first digit in the unsorted list. So sorted. Actually, I should have just copied down the one from above. You could just write S and U above the ones and put a little line. So you then look at this data. Okay, we're looking at this one, the 9. Right, so you go through the list to see where the 9 will fit. So will it fit there? Yes, it's less than there. So you put like less than 12. You look at that one. So then the list becomes what I said to you before, that it's not good for an exam because look, there's just so much writing to explain what's going on. It's not a very difficult process. It's just that, write an answer. So now we've got a sorted list and then an unsorted list. Now it's not too bad, these first ones, because they are like going to go in at the start. I just realised I got that around the wrong way. So now I've got to stop that. Data go there. 9 and 12. Right, sorted, unsorted. And then we're going to check 3. And then we go less than 9. So we check that. And then it goes down and on and on and on. And you can see how this can get quite annoying because they've already only done a couple and we've got loads more of sorting to do. But anyway, so 3 goes in there. I'm going to show you 15 because fortunately that's one that isn't going to go right at the start. So you can see how this would carry on and on and on. So as it goes on, this is sorted. This is unsorted. Right, now we're looking at 15 and it goes, so I would draw less, no, too big, less than 15, less than 15, less than 15, and then goes at end, something like that. And if it wasn't, if it was like more than that, you'd say, right, goes between here or something. It's quite difficult to really describe it well with it on paper. That's why I don't think it'll be in the exam. But I could always be wrong. So sorted, unsorted. Just keep stretch that out to there, and you get the gist. You've now got up to here, and we've got copy that. So that's how you do it, basically. Go through with a sorted and unsorted list. If you want to see how complicated it is, that's what I'm saying. I can't see how they would put it in the exam because this is the steps. Look, look how many there are. Look, loads of them. Look. So here's one sorted, unsorted list. Look at this element, put it in. This is them showing how you got to check each one to go through. It's quite a lot of steps to show how to do it, but that's basically what you would do. I mean, if you had a big one, you might just have to go from putting it like that into the right place and just say something like it was that is where it fit or something. You literally jump from say 15 being 3 being here to having the list sorted and just saying that the list was I checked and 3 went first and I checked and 3, we checked each number. But that's why I like to draw these little numbers here because it does a lot, because rather than having 3 lines where I go, they do it each side. They go like, oh, check if it's 9, check if we should go here, check if we should go here. I'll just go like that, less than 15, less than 15, less than 15 goes at end. And that's like 4 steps of their one. Because otherwise it could just get massive, and I don't see how you could possibly put that in an exam. But I very much doubt insertion sort's going to be there. Very much likely they'll do merge sort or bubble sort because they're a lot easier to have a much stricter mark scheme on, because this one's a lot more about how you display it rather than the others. Whereas merge sort's always the best one for an exam because there is only really one right answer. I mean, there obviously is only one right answer to an insertion sort, but what I mean is how you draw it out can be done very differently. Like there, I have just shown the steps as in, look, less than 15, less than 15, less than 15 goes at end. Well, they've written out their steps. Compare 15 to 3. It is smaller. 15 is bigger than 3, sorry. Compare 15 to 9, and a whole step for that. Now, you could be, how would you write that in an exam? That's why I think it will just be one of the other sorts.